So part 4 circles we have to do now. 10.2 question number 2. Question number 1 we did. In question number 2, if chords of congruent circles subtend equal angles at their centers. So here angles are equal, means these are the two chords. AB and CD are two equal chords in these circles. Let AB and CD not equal. We have to prove that chords of congruent circles be the chords of two congruent circles. This circle we denote by CO, center, R, radius, and another is C dash, center is O dash, and radius is same because they are congruent. Now here it is given that equal angles, they are subtending equal angles. That means this angle is equal to this angle. Angle 1 is equal to angle 2. Okay. Then the chords are equal. We have to prove that the chords are equal. So given that angle 1 is equal to angle 2, and to prove that chords are equal, to prove that AB is equal to CD, the chords are equal. This we have to show. So now consider these two triangles. In triangle AOB and triangle CO dash D. In these two triangles, if we prove these two triangles to be congruent, then all sides are equal. AB will be equal to CD. That we have to show. So AO is this one. This is equal to this one, CO dash, because they are the radius of two congruent circles given. Therefore, we can write AO is equal to CO dash. Someone with name AIM trying to enter, I will not allow him to enter with the wrong name. Okay. AIM, who is AIM? I don't know. So AO is equal to CO dash. Then another side BO is also equal to DO dash. So this is because the radii of, okay, I'll see, admit, of congruent circles. Okay. Similarly, that OB is equal to O dash D, reason is same. Before that, we should write side angle side. So we used to go by sequence side angle side, but in some books, in some refresher side, so they are not. maintaining the sequence, but we are maintaining sequence, therefore side, then angle 1 is equal to angle 2. Why? Because it is given that these angles are equal, then O, now we can write OB is equal to O dash D. The reason is same. This reason you can write here. Therefore, by SAS congruency, triangle AOB is congruent to triangle CO dash D, and by CPCT AB is equal to CD. Chords are equal by CPCT. This proves the theorem. Theorem 10.3. The perpendicular from the center of a circle to a chord bisect the chord. Means this is O is the center. From this OD is perpendicular. This is given, it is a perpendicular. We have to show that this bisects the chord. So what is given in circle COR AB is a chord and OD is perpendicular on AB. This is given only, this is perpendicular. Now we have to prove that it bisects the chord. To prove that bisects the chord means OD bisects the chord. OD bisects AB. That is, bisect means dividing into two parts. AD will be should be equal to DB. This we have to prove. AD is equal to DB. So it's very simple. We can use RHS. These two are right angle triangles. So consider these two triangles, AOD and BOD. In triangle, if we prove these two triangles are congruent, then AD will be equal to DB. So in triangle AOD and triangle BOD, RHS, right angle first. So angle ADO is equal to angle BDO is equal to 90 degree, right angle. Why it is right angle? Given that it is perpendicular, so both sides it will make right angle. R, H, hypotenuse. So hypotenuse of AOD is OA, AO. So AO is equal to BO. AO is equal to BO because this is radius. This is also the radius of the same circle. So these are the radii of the same circle. They are equal radii of same circle. Okay. RHS, one of the sides we have to prove equal. This is common side. So we can write OD is equal to OD. This is a common side. So therefore by RHS, Therefore, by R H S congruency, we get triangle AOD is congruent to triangle BOD. When they are congruent by CPCT, AD will be equal to DB by CPCT, hence proves that perpendicular OD bisects AB. OD proves that OD bisects AB. That was required to prove. So they can make it as a question. They will write prove that. Instead of giving the same, they will write prove that the perpendicular from the center to a chord bisects the chord. Theorem 10.4. The line drawn through the center of a circle to bisect the chord means now this is center. From this a line is drawn which bisects the chord. This line bisects the chord. This line bisect the chord OD. OD is a line, not perpendicular. This is bisecting the chord AB. This is AB, and we have given it is bisect the chord, means AD is equal to DB. And we have to prove that it is perpendicular. OD is perpendicular. So this is the converse of the previous theorem. So what we have given a circle in a circle C, center O, RB radius, AB is a chord, and AD is equal to DB. AD is equal to DB. Then to prove that it is perpendicular. To prove that OD is perpendicular on AB. First of all, these two triangles, prove these two triangles congruent. Then we have to prove this is 90 degree. Triangle AOD and triangle BOD. SSS can be applied here because this is the radius and this is also the radius. So AO will be equal to OB. Why? Because these are the radii of same circle. Then OD is equal to OD, common side. OD is equal to OD, common. Then AD is equal to AD given. AD is equal to BD. Yes, this is AD is equal to BD. This is the given condition. Therefore, by SSS congruency, triangle AOD is congruent to triangle BOD. When it is congruent by CPCT, you can take this angle number 1 to better to understand. That is angle number 1, this is angle number 2. So these two angles are equal. Angle 1 is equal to angle 2 by CPCT. But angle 1 is equal, angle 1 plus angle 2 is equal to, angle 1 plus angle 2 is equal to 180 degree. Why? Because they are linear pair of angles. Linear pair of angles. So linear pair means on a straight line two angles you make, that they are called linear pair. This is a straight line, and line coming here. These two angles sum will be always equal to 180 degrees. So they are called linear pair of angles. And both are equal, both 180, or we can put, instead of 1 we can put angle 2. From this we can put angle 1 is equal to angle 2 plus 2 times angle 2 is equal to 180 degree, or 2 times angle 2 is equal to 180 degree. So angle 180 degree and angle 2 is equal to 180 by 2, 90 degree. So each 90 degree. Therefore angle 1 is equal to angle 2 is equal to 90 degree. That means what we have to prove, that this is perpendicular. So both angle are 90 degree. That means OD is perpendicular to DB. It implies that OD is perpendicular to AB. I think OD is perpendicular to AB. Yes, this one we proved. OB is perpendicular to AB. That means the line from the center of a circle to a chord is perpendicular to the chord always. So these two theorems will be used in the next exercise. One more theorem is there. There is only one circle passing through 3 non-collinear points. So one more theorem we will do today in the next class, and then we will start exercise 10.3.